Here are a couple of compound interest questions. I'll do them in the efficient method to begin with and then explain where those formulae come from. So if I use the compound interest formula for the first one, so Sam starts off with £5,000. The interest rate is 2.8% and it's over 4 years. Put that into a calculator and you come out with £5,583.96. For the second one, Andy starts off with £12,000. In the first year, he earns 2%, second year, 3.5%, in the final year, 5%. Put that in a calculator, you get £13,301.82. And that's it. This was worth 3 marks, this was worth 2 marks. But how does it all work? Let's start off with the first one and try and work out where these things come from. Start off with the 5,000 here. It's fairly obvious that this is the starting value here. Next one is the 4 years, so it's to the power 4, and then the 1.028. This seems to have something to do with the 2.8% up here. Question then is what? I'll start off by working this out longhand. In year 1 we're going to have 2.8%. 2.8 over 100 percentage of 5,000. So from that we're going to get 0.028 times 5,000. Should get £140. And then because it's compounded, we then take the 140 and add it to the original 5,000. So at the end of year 1 we have £5,140, and then you put that into year 2, and so on. Now it looks like we've got the 0.028, but we also need to get the 1. This actually comes because we're adding the original 5,000. Let me explain in a bit more detail. What we're doing is we're doing 5,000 plus 5,000 times 0.028. If we collect terms, we end up with 5,001 plus 0.028, and that's 5,000 times 1.028. So that's the end of first year. We move on and look at year 2. Previously we started off with £5,140, which was the result of year 1, which I'll just make a jot down here. Instead of this, I'm going to put in this. So I'm going to have 5,000 times 1.028, which we know equals 5,140. So we'll move that over to one side so you can see it more clearly, that the 5,140 here becomes 5,000 times 1.028, and then I'll go back and put this in. So at the end of the second year we've got this slightly longer calculation here, where we've started off with the 5,000. We've got the first year's interest rate there, and then the interest rate here for the second year. And similarly, if we go into year 3, we'll take this amount here, 5,000 times 1.028 times 1.028, and we'll be multiplying it again by another 1.028. At the end of year 4, all that again, and the fourth year's interest. And then you can see this final calculation that we came up with was we start off with the 5,000, that's come down from here. multiplied by 1.028, and we do this 4 times. 1, 2, 3, 4 to the power 4. And that was our original calculation. That gives us 5,583, 962,113 on a calculator, and we round it to the nearest penny. Okay, so let's move on to the second part of the problem. And you can see here that it's compound interest again. But in this case, the interest rate changes. So the first year is 2%, second year 3.5%, third year 5%. This means that if you just think, oh, it's compound interest, I'll just use the compound interest formula, capital times interest rate to the power years, which is what we did in part A, it's not going to work because the interest rate changes every year. And then, okay, does that mean I have to drop and do it manually? And yes, you can do it manually, but there's a quicker way, as I did earlier. If we look at this, you can see that I've taken the original capital of 12,000, I've then multiplied it by the interest rate for the first year, multiplied it again, the interest rate for the second year, and then the interest rate for the final year. And this is actually very similar to part A. On the line before, we converted it to the interest rate to the power 4. So if we just go back and have a look, you can see here we started off with a capital, first year, second year, third year, fourth year. The interest rate was the same on every one, so we were able to combine all of these into a single to the power 4 here. Part B, exactly the same idea. The difference is that the interest rate changes. So this was year 1, this was year 2, this was year 3. And other than that, you just put it through a calculator.